So far, the only angles that we've talked about in a circle are central angles, those angles that had their vertex on the center of the circle. Today we're going to add in 3 other angles. The first is the inscribed angle, and this is probably the most important of the 3. An inscribed angle is an angle that has its vertex on the circle. So you might write that, your vertex on the circle. And then we've also got a new piece here because we're looking at this vertex on the circle. An important part of an inscribed angle is its intercepted arc, which just means the arc that is created on the inside of that angle. So if we continue that out, our intercepted arc is this arc right here. And it just so happens that inscribed angles always end up being half of the measure of their intercepted arc. So if we knew that the measure of this arc was 150 degrees, then our inscribed angle automatically would be half of that, 75. Also recall that an intercepted arc like this gets its measure from the central angle. So if the arc measures 150 degrees, then the central angle would measure 150 degrees, but the inscribed angle would be half of that. Because of the way that inscribed angles work, they have a few cool properties. So our first example is just 2 inscribed angles. So we've got this green inscribed angle and then the black inscribed angle as well. And both of these have the same intercepted arc. So if they both have the same intercepted arc, and for inscribed angles, we just learned that it's going to be half of the measure of its intercepted arc. That means that these are going to end up being congruent because our green angle, since it has an intercepted arc of 100, will end up being 50 degrees. And then the same thing happens with our black angle because it is going to be half of 100. So you could say inscribed angles with the same intercepted arc are congruent. They have the same measure. Then our other cool feature that this has, if we have an inscribed angle that has an intercepted arc that is a semicircle, because our semicircle is always 180 degrees, that automatically means that the inscribed angle has to be 90. So it has to be a right angle. So it is a right angle. Our last 2 types of angles don't have special names, but we're looking for the situation where the vertex is inside the circle or the vertex is outside of the circle. And for both of these, notice that we've got 2 different intercepted arcs that we're talking about. So for angle X, it intercepts this arc on this side, but then that angle continues and it intercepts this arc on the other side. Same thing for being outside of the circle. The 2 sides of this angle intercept this small arc, and then it also intercepts the larger arc. So in order to find the measures of these angles, it's going to include both intercepted arcs. So if we're inside of the circle, we're going to find X by taking the average of the intercepted arcs. So for example, if they told us that this arc was 100 and then this arc was 40, we would take our 2 arcs and say that X equals 40 plus 100 divided by 2. So adding them, dividing by 2, and we should get 70 degrees. We have to be a little bit careful on this that we're choosing the correct arcs. If we were talking about this angle instead, then we would be talking about this intercepted arc and this intercepted arc. So always whatever that angle opens up to. For outside of the circle, it's still going to include both intercepted arcs, but instead of taking the average, we're actually going to subtract them and divide by 2, or half of the difference. Of the intercepted arcs. I've had students in the past call this the daverage because instead of adding them, you're taking the difference That is not a real word, but if you want to use that to remember it, you can, that we're taking the average. So in this case, let's just use the same angles. If we had 140, that looks kind of small for 40, but that's okay. We would be taking 100 minus 40, and you're always just subtracting the smaller angle, so don't get too mixed up on which one has to be first. You don't want a negative angle, so put them in the order to where there's not going to be a negative angle, and then we're dividing by 2. So in this case, we'll have that 60 over 2, which makes x 30 degrees. So for any example involving angles in a circle, we first just want to decide where that vertex is, because that's going to determine how we solve for the angle. So in this first example, if I'm trying to find a central angle, remember that it's going to be exactly what that arc measure is. So in this case, it would just be 50. If we have an inscribed angle where the vertex is on the circle, then it ends up being half of the intercepted arc. So in this case, x would be 25. If the angle is inside of the circle, but it's not a central angle, that's where we're adding together the two intercepted arcs and dividing by 2. So taking the average, we get 40. And then our last case, if we have the angle outside of the circle, we're taking those two intercepted arcs, subtracting them, and dividing by 2. So we'll get 10 degrees. Okay, so let's look at some examples together. And also, sorry for the dark lighting. It's kind of gloomy outside today, and I rely on the natural light of the sun for these videos, so sorry about that. But I think it's still light enough that you can see it, hopefully. So for our first example, we're noticing that the vertex is on the circle. So even though this is a tangent instead of, we actually call this guy a secant, it's still an inscribed angle because the vertex is on the circle. So that means that our angle x is going to be half of our intercepted arc. So we're just saying, okay, x is going to be 148 divided by 2. So 74 degrees. That's all there is to it. 2 looks pretty similar because the vertex is still on the circle, so I know that this is going to be half of its intercepted arc. But this one is a little different because I don't know the intercepted arc. So I've got 2 different ways that I can go about this. One of the ways is to say that the whole circle is 360. So if I subtract 200, that would make this arc 160 degrees, and then to find x, I could take 160 divided by 2. The other way that we could go about this is finding the angle next to x. So if I take half of 200, it would tell me that this angle right here is 100 degrees. And then because x and 100 are supplementary, they're a linear pair, I know they have to add up to 180. So I could subtract 180 minus 100, and that would get me 80 as well. For number 3, now we've got an angle outside the circle. So this is the case where I'm subtracting the 2 intercepted arcs and dividing by 2, but I am missing an arc. So I've got this one, but I'm missing this one. Because these are tangents, so they're just touching in one place here, and usually in your directions they'll tell you that. That means that if I subtract 360, minus this 210, I should get what's left over. So if I do that off to the side, and I get 150, now I've got both of my arcs in order to subtract and divide by 2. So this is my x. Let's see, we'll get 60 divided by 2, so x ends up being 30 degrees. Sometimes we might need to find some things. For our last example here, our vertex is inside of the circle, but not a central angle. So I want to use that average of the 2 intercepted arcs. So we've got 170 divided by 2. Okay, 85 degrees. I do want you to try some on your own, so go ahead and pause the video and try these 3 examples. In each one of them, you're just trying to solve for x. So So starting with example 1, this is kind of backwards from what we've been doing because we're given the inscribed angle and trying to find the arc. But as long as we remember that the inscribed angle is just half of that intercepted arc, that means that our intercepted arc in this case would have to be double. So it'd have to be 2 times 40, which is 80. For example 2, notice that we are not actually given the intercepted arcs that we need to find x, but we can use the intercepted arcs that we're given to find the angle that's next to x. So if I use my 30 and 90, because the angles are inside of the circle, I want to add them and divide by 2. So finding that average. And we get that the average, I went off screen a little bit here, but 120 divided by 2, we'll get 60 for this angle right here. And also this angle, since they are vertical angles. So going from either one of those to x, they are a linear pair, so I know that 60 plus x has to equal 180. And then subtracting 60 from both sides, I get that x would have to be 120 degrees. So for our last example, we're finding an angle outside of the circle, so I should be subtracting the intercepted arcs and dividing by 2, but I'm missing that second intercepted arc. So in order to find my missing arc, I would need to add all of these together and subtract from 360, because I know that my 130 plus 100 plus 80 plus my missing arc, so if I want to name it something I can, all has to add up to 360. So if I add these all together, I'm going to get 310. And then subtracting 310 from both sides, I get that this arc is 50 degrees. So now that allows me to use what I've learned, that x is going to be 130 minus 50 divided by 2. So an 80 divided by 2, or 40 degrees. And that's it. You've made it through your last lesson of distance learning. I just wanted to say thank you for those of you that have been doing this the correct way, watching the videos and actually learning from them, taking notes, working through the homework, and actually trying to understand the concepts rather than just breezing through all of it. I just so appreciate that myself, but also know that having integrity will always be beneficial in the long run. So work through this last practice assignment. We'll have our last assessment on Friday over circles. And then if you have completed everything, then you are done, and have a great summer.